Welcome to the present class, and in this video we are going to see one of the previous year question related to UGC net 2024 question. Okay, so here it is a question which is related to signals and systems. Fine. So before going to start the solution for this question, here one small announcement is that if anybody of you or else your known ones are preparing for the UGC net or else the set examination for 2025, then here I am providing the 1000 previous year questions course. Fine. So this course will be really helpful to the candidates who are seriously preparing for the examination. So that it will be helpful to crack the exam. So whoever the candidates are interested to take this course, then the candidates may just express your interest to this provided WhatsApp number, or else in the description box of this video I kept the WhatsApp group link, so the candidates may join in that group to get the updates regarding this course and all. Okay, if you are interested for this course, then only you just join in the group link which I provided in the description box of this video, and the course fee will be approximately 1000 rupees. Okay, so here the 1000 previous year questions means nearly the 10 previous year question papers will be covered, and if you can able to understand and digest the concepts related to 1000 previous year questions, then it will be very easy to crack the exam. Fine. And now while coming to the present content of this video, so it is the question we are going to see. Fine. So have a look at this question. Yeah. So here they took one LTA system. LTA system is nothing but a linear time invariant system. So there are few conditions are also there to check whether the system is linear and a time invariant or not. So whenever that related topic question we got, then we will discuss deeply about whether the given system equation is a linear or not, or else whether it is time invariant or not. We will check about all those details. So currently we will discuss and we will focus only the concept which is related to this question. So here they gave the output of the LTA system. So let's take it is a LTA system, okay, and it is a y of t, and the input can be taken as a x of t, and each and every system is having its own transfer function. So let's take its transfer function is h of t. So now y of t can be taken as a transfer function h of t convolution x of t. We can take it as like this. And if you don't want to get the convolution, why? Because convolution related concept is different, and to solve the expressions with respect to convolution, it will be the time taking, and we don't have that much of time in the examination. So that's why we have to convert this convolution into multiplication. Then we have to convert this time domain signal into frequency domain signal, that is Laplace we can convert, that is y of s can be taken as a h of s into x of s. Okay, so like that we need to convert the time domain to Laplace domain so that it will be very easy to solve the given question within the given time. Fine. Okay, so now here in the first case, so if you observe from here to here, one case is there. So from this case here they provided the y of t as well as the x of t. Okay, so with the help of the y of t and x of t, we need to find out the transfer function of the system. And then the second part of the question is they changed the input and they're asking to find the output for the same system. Okay, so now if you consider the first part of this question, y of s, it is the output, right? So y of s basically e power minus at into u of t. The Laplace transform of this one can be taken as a 1 divided by s plus a. Okay, so in the same way, for this one the Laplace can be taken as a 4 divided by s plus 3. Okay, it is a y of s, right? That is equal to h of s we have to find out, h of s into here the x of t is given as u of t. So for the unit step signal, the Laplace transform, that is x of s, for the unit step signal is 1 by s. Okay, so from this way we can find out the transfer function of the system is 4s divided by s plus 3. So it is the transfer function of this system. And for the same system, they gave the input as e power minus t into u of t, and they're asking to find out the y of t, right? So let's have a look. As usual, y of s is equal to h of s into x of s. And for the second portion, actually the system is same, right? For one single system, for the same system, h of s is fixed. So we can take 4s divided by s plus 3 into x of s. For the same system, next time they change the input to e power minus t into u of t. That is, we can take 1 divided by s plus 1. Okay, with the help of this formula. So here a is 1 in this case, so 1 divided by s plus 1. Now it can be taken as 4s divided by s plus 3 into s plus 1. Okay, so now we can't directly take the inverse Laplace for this one. So what we are going to do is that we are going to take the partial fractions. So a divided by s plus 3 plus b divided by s plus 1. So we can take this one as like this. Okay, with the help of the what we call partial fraction concept. Okay, and then if I do the LCM, what I will get? A into s plus 1 plus b into s plus 3 divided by s plus 3 into s plus 1. Okay. And now what I am going to do is that by equating both these two, that is 4s divided by s plus 3 into s plus 1. If I equate both these two, both the denominators will cancel. Okay, then what I will get? If I equate the numerators, then 4s is equal to as plus a plus bs plus 3b. Now, both the two sides from LHS and RHS, you just equate the coefficients. Here the LHS side, the s coefficient is 4. Here the s coefficient is a plus b. Okay, in the same way, both the two sides equate the constants. Okay, here the LHS side, the constant is 0, and RHS side, the constant is a plus 3b, right? So now with the help of both these two equations, let's take here 0 is equal to a plus 3b. Now if I solve both these two, then what I am going to get? Minus, minus and minus. A and minus a gets cancels. Here I will get minus 2b is equal to minus 4. Sorry, plus 4, right? 4 minus 0 plus 4. So from this one, b is equal to minus 2 I will get. Okay. So if I substitute the b is equal to minus 2 in this equation, then how much a I will get? A is equal to minus 3b, that is 6. So a is equal to 6 and b is equal to minus 2. If I substitute both these two here, a is equal to 6 and b is equal to minus 2. Okay. Now if I take the inverse Laplace transform for this one, now what I will get? 6 into e power minus 3t into u of t minus 2 into minus 2 into e power minus t into u of t. So it is the inverse Laplace transform for this one. That means we got the thing in the time domain. Okay, why? Because the options also given in time domain, so we need to convert the s domain to time domain finally. Now we can take minus 2 e power minus t plus 6 into e power minus 3t into u of t. So it is the final answer. Okay, so let's check. Here we got minus 2 into e power minus t plus 6 into e power minus 3t into u of t. So we can take option 2 is the correct answer. So from this question, what you have to make a note is that it is the first one, and it is the second one, and it is the most important thing. So from here to here, to convert the time domain to Laplace domain, from here to here, inverse Laplace to convert the S domain to time domain. Okay. So, and this one, and here the partial fraction concept. That means how we are converting this one to this one. Okay. So these are all the important things. So total how many parts? Total 4 parts. So 1, 2, 3 and 4. So if you know all these 4 things, then it will be easy to solve this type of questions. Okay, so I hope all of you understood. So apart from these things, if you are having any doubts related to previous year questions, you just keep out your doubts or the questions in the comment section, so that I will come up the solution for those questions in the next video. Okay. Anyhow, thank you very much. And before closing this video, I just want to remind one more time, if anybody are preparing for the UGC NET or the SET examination, then I am providing the 1000 previous year questions course. Okay. So interested candidates may take this course, and this course will be really helpful to crack the NET or the SET examination. And you just express your interest by just WhatsApping to this number, or else I kept the WhatsApp group link in the description box of this video. Okay, the fee will be approximately 1000 rupees, and only interested candidates WhatsApp me or else join in the WhatsApp group. Okay, thank you.